We'll start in 2 minutes.
Ik ben er.
Yeah, now we can hear you, Arnold. Perfect.
I don't know what happened, but always nice to have a little stress with the audio.
A technical challenge.
Technical challenge. We'll wait a couple of minutes. We've got about 50 people attending today, so that's good. The number is up. It's going up 26, 27, 28. So Tuesday mornings, always nice. Going to 30. Javier, welcome. You see my screen. We have people from all over the world again, so it's nice to see that the subject attracts so much attention. So, as we're a Dutch-German company, we're precise. It's past. Let's start with the webinar. Thank you very much for joining us for hopefully 45 minutes up to an hour of presentations on the subject of UV-C. I have with me today Mr. Rob de Heer. It's the bald man who will do the presentation. The agronomist, pitch consultant, 30 years of experience, but he will give his own introduction shortly. Tom Matthijs, our business manager led, and Andreas Schweiger of the University of Munich, who's been researching UVC and light and the relationship between LED and light to a large extent. Maybe as an introduction, I start with you now, Andreas. Last time I started with Rob. Can you give us 2 minutes on your background and what it is you do?
Thank you, Arnold. First of all, welcome everyone to joining our seminar here. My name is Andreas Schweiger. I'm researching at the Technical University of Munich. I did my master's thesis here on the Technical University, also in the field of LED lighting of plants, and now I'm researching in the field of light management, lighting in quality and in intensities in the different spectra and the effects on the growth and the development of plants, and now specialized in the field of the turf grow and the interaction with the LED light. Yes, and so I'm the scientific part of this webinar today.
Okay.
Thank you.
Thank you very much, Andreas. Tom.
Hi, good morning, everybody. My name is Tom Matthijs from Belgium. I'm the business manager with RSI Rhenac for everything that is concerned the LED light spectrum, so CLS, complete light spectrum for grass growth, and also for UVC. This is a topic of today, the effect of UVC light on the grass diseases. So very welcome. I'm glad that you took the time to join our webinar, and yeah, I hope it will be interesting for you.
Rob?
Yeah, the only part missing is the practical part now. We've got the science and the marketing and the business model, but also systems need to be implemented. My background is an engineering background. I'm an engineer, land and water management. I'm in the sports pitch construction industry since 1990. Started off in golf course construction and moved towards well, general outdoor sports facilities construction, design and construction of pitches. did a lot of returfing operations in stadia all over the world. So yeah, I've got quite a few references there. Arnoud, over to you.
My name is Arnoud Violet. I'm the one of the partners of the RSI Rhenac company. Next slide, Rob. Okay, topic of today, UV-C, grass disease management, algae fungi, eco-friendly alternative. I think it's very popular. I don't need to explain to the people on board the importance of sustainable methods to maintain natural turf. So if you have the next slide, Rob. Rhenac GreenTech, RSI is a combination, is the market, the sales and marketing body of the Rhenac GreenTech AG. Rhenac GreenTech AG is a very focused company on LED and the relationship between LED and a number of elements. Started off over 12, 13, 14 years ago. In the meantime, a publicly listed company, 3 business units, bio, flux, which is architectural and sports, especially after World Cup 2010. Can you become active in the natural grass from a German perspective? And since then, they've done, as a typical German company, have been researching and started researching to understand the relationship. The last one in line, but not probably the last one in line, is Andreas, who's doing his master thesis on the relationship between LED and UV-C, LED and grass. Here I'd like to give it to you, Rob, as the presenter of today. Of course, the 8 years of study is there, and Rob, please take it over.
Yeah.
Enjoy the presentation.
Thank you. Yeah, we'll start with a little bit of history. 2 weeks ago, we had a similar webinar, and some of you attended that webinar as well. But I'm aware some of you didn't. Some listeners. That webinar was about the relation and the research we've done between the relation between LED, grass grow lighting, and the reaction of the plant on that. I just want to summarize what we discussed because part of that will actually come back into the UV-C presentation of today. So basically, the complete light spectrum system that we've developed, the CLS system, is able to give all the possible photosynthetic active radiation that a plant needs, variable during the day at any intensity at any time in the day. So basically, it's a complete flexible system. Whereby we can change the type of light that we apply. And research has actually shown that that is exactly what the plant needs, because different light spectra focuses on different ways the plant grows. For example, blue light increases the sward density and tillering. So basically you get denser pitch, more shear strength. It increases root development. But it also helps into reducing the amount of diseases on the grass, and I'll come back to that later in this presentation. Whilst the red light predominantly is active to create length growth of the plant, and which is nice if you have an event upcoming and you want to create more biomass and a better visual performance. But it doesn't necessarily give you the strength that a football pitch needs for play. It also helps to increase the germination of newly seeded grass and to develop grass from a seedling up to a dense sward. Especially the cold season grasses react on red light in that respect. Whilst on the other hand, white light helps germination for warmer season grasses like paspalum and Bermudas. But it also, white light helps in balancing any shortcomings of the other types of lights. Basically, white contains all the broad spectrum, and it helps to find the balance in the application. So what we've shown in that presentation is that with our system, the CLS system, we are able to give you the complete spectrum of the photosynthetic light and in any intensity. And as you can see on the graph on the right-hand side, we can apply light when, for example, you want to create length growth or you want to create more density. We can play around with the applications. In the left-hand corner below, you can see the visible light spectrum with the appropriate wavelengths in nanometers. And completely on the left-hand side, you can see the ultraviolet part, actually everything below the 380 nanometers. And that's the part we're going to discuss with you today, because that also has its benefits. So what was our aim with developing the UV-C system? Arnoud.
Rob, can I just intervene for just one second? I forgot something before we go into the presentation. There's a question box on the right-hand side where you can pose questions. We will try to answer the questions at the end of the presentation. If not answered today, then we will collect all the questions and send all the questions plus its answers all out to all the people involved. But feel free to ask the questions if you want, and we'll come back to that at the end of the presentation. That's what I forgot to say earlier on.
Okay, we'll continue. So what was our aim developing the UV-C light spectrum treatment? Well, first of all, to assist the grounds managers to reduce the susceptibility to disease of the plant, and basically to create a plant that's better able to defend itself against pathogens like fungal diseases. And also, as part of that, to develop a practical means to actually apply that on a sports pitch or a golf course where it's needed, because that's an important part. You can develop the best scientific methodology, but if it's not practically possible to apply it on your pitch, then it doesn't leave us anywhere. So we thought of that, and at the end of the presentation, we will give you the ins and outs of the machines that we developed. Where do we see the applications for UV-C treatment? Professional stadiums and training grounds. That's the obvious one. Stadiums typically have a hostile environment for grass growth. All stadium managers amongst us will know that. They will struggle on a day-to-day basis, keeping their pitch healthy and green. In some areas, as you can see in the picture on the left-hand side in the top, you can see there's part of the grass is in bright sunlight, but most of the time a lot is also in shade. And if it is in the sunshine, it's definitely not there for the complete day compared to the outside situation. But also golf greens and golf tees, not to forget those. Usually golf courses are beautifully landscaped, nice large trees around the greens and the tees, basically creating a similar environment as you would find in a stadium. And also the grasses used on golf greens are typically more in stress than they would be on a training ground because of the close mowing and the treatments that it receives. Other applications that we see is artificial turf. Everybody will think, well, what would you need with artificial turf? For example, hockey pitches, water-based hockey pitches or semi-water hockey pitches, basically are moist the complete day, the complete year, and there's a lot of disease fighting in algae, especially in certain times of years when the algae explodes, and that's definitely an application that we're looking at. Public parks, everybody knows the little gravel roads or pathways in parks. Often in shade, they become slippery as well in the winter because of algae, and that could be a treatment way of treating it as well. So what do we need? We need to understand the preventative function of UV-C light. We know UV-C light is able to attack lower organisms like algae and fungus, but it's not only the UV-C light that will work. It's also, you need to understand the climatic conditions, the irrigation conditions of a stadium, how moist is it, nutrient levels, the maintenance procedures that are taken by the ground staff. Basically, it comes back to creating a healthy plant, because a healthy plant is not that susceptible for disease. And every tool that you can bring in to help creating a healthy plant is a bonus. And one of them is UVC light. If you look at the main diseases in our region, the cool season turf grasses, let's focus on those. The analogy applies to the warm season grasses as well, but most of the listeners are working on a daily basis in the more moderate regions using cool season grasses. There's a lot of them. Leaf spot, fusarium, you call them dollar spot, red thread. Most groundsmen would have seen them on their pitches. Greenkeepers would have seen them on their greens. It's a wide variety of fungal diseases. Some of them will be attacking lolium. Some of them will be primarily on bent grasses or fescues. There's a wide variety, and it's the groundsman's nightmare to have those in their surface. And as I said, with artificial turf, algae is a big problem, and we're actually starting to test the system on 2 artificial turf surfaces in Holland this week, just to see if we can reduce the amount of algae in the live situation. The research that we've done, and Andreas and his team have done, is focused on grey leaf spot, not without reason. Probably not the most common fungus in sports fields. Then we're more looking into fusarium or red thread. But grey leaf spot is a disease that's more and more prominent in stadiums and training grounds over the last few years. It appears primarily after warm and humid periods. So we're not that there in Western Europe. It's getting warmer, but it's still very dry. Which helps, but definitely when the rain starts and the temperature goes up, this is a disease that's really coming into the surface. So we focused, and the next slides that we show, that we focused on the research on this particular disease, but the applications and the way we've researched it would be applicable to most fungal diseases. The UVC light spectrum that we've used, it's well, the general UVC light spectrum lies between the 200 and the 280 nanometers. But we know that part of that UVC spectrum in particular is actually attacking into the DNA of a large number of pathogens, algae, fungi, etc. And that is between the 254 and the 262 nanometers, which is a really narrow bandwidth. And that's right away. That's what we had to look at. How can we actually apply that amount of light in that particular spectrum in our tests? And we've managed to do that with our LED system. We found that the UVC light can reduce the spread of fungal diseases and their sporulation, and we'll come to that in the next slides. Typically, UVC light has a very short wavelength. It's very powerful, and it's effective in short bursts. Not for nothing that it's not without a reason that UVC is being blocked by the ozone layer in the atmosphere. UVA and UVB are able to actually penetrate through the ozone layer onto the Earth's surface, and that gives us a nice brown tint in the summer. But UVC luckily is blocked, because if that's not blocked, it would actually destroy a lot of life in the world. And it's also used in all kinds of applications. For example, water treatment plants to sterilize water, or even to sterilize medical equipment in hospitals. UVC is a well-known treatment for that. It does not destroy biologically higher class organisms if you treat it the way we want to treat the algae. Of course, if you give the long-term treatment, it will kill everything. So in the picture, you can actually see the machine that's built to apply the treatment, and it's nicely covered. So it's once it's on the ground, it will not distract any radiation outside the treated area. So it's safe to use. The questions that we've asked ourselves is basically there are four, and the first one is, can the scale of fungal infection be reduced by a UVC application? So basically, if you have an infection on your surface and you can see spots of 5-10 centimeters in diameter, can that be reduced as a reactive measurement and treatment? But can we also work preventative in the formation of spores? Can we reduce that by UVC applications? And what doses, if UVC is needed to slow it down? How high dose do we need to apply, and for what time period do we need to apply it to get the optimum results? And till what dose can we actually apply it without the grass getting negative effects of that treatment? Basically, it will scorch or burn the plant if we apply UVC light too long or in too high intensities. So it's again finding the right balance, and that's the trick, and that's what the research actually focused on. So the grasses that we used for the research or for the grey leaf spot were typically Lolium perenna multiflorum, and Festuca undinacea. On Poa pratensis, we could not find any infection of infected grasses by this particular fungus. How to identify it? It gives the fungus gives a grey discolored spot on the leaf, typically, and it's somewhat brown when it's in a later stage around that grey spot. That's how you can see it. And if you look at the picture on the right hand side to see, you can see the spores, and they have this nice pear-shaped form, and that's actually why this typical fungus is named as it is. It refers to the pear. The conditions that this particular disease will appear is when temperatures are rising above 28 degrees, but also the nighttime temperatures are above 20 degrees. In this period of year, in Western Europe, the nighttime temperatures still drop till 3 or 4, even maybe up to 10 degrees, and there is less susceptibility for this particular fungus. So you're looking more into May, June time that it starts. Favorable with high humidity, continuous leaf moisture. That's why most greenkeepers sweep their greens every day, and to get the leaf moisture off. And I can see that more and more in stadiums and training grounds as well. Leaf sweeping, a good method. High intensity of sunlight helps as well, scorching the grass. Basically, it weakens the plant, and the plant is more susceptible for infections. And also constant change between dry and humid periods. So if there is a change in that, and typically in a stadium, you have that on a day-to-day basis, because it will be dry in the afternoon, but it will be moist again in the morning, and the same applies on greens between the tree lines. The height of cut, the closer you mow, the more in stress the plant will be, and the more susceptible it will be. Fertilizer levels, very important. If there is a too high dose of nitrogen in the plant, that means there is less sugars in the plant, it's less healthy, and it will be more vulnerable for disease. Also, leaving grass clippings on the surface is not a good idea, because it can actually spread the disease quite easily. But also cross-contamination. Often found that if you use equipment in stadiums and at the same time or the same day on the training ground, you can actually cross-contaminate spores and bring it from one place to another. This also happens by the players themselves. If they play and train on the training ground and the boots are not cleaned before they enter the stadium, then this is typically the way it's migrating. Greenkeepers often have the same problems. If diseases that are predominantly available in the US come over to Europe, that often goes through the players themselves. They didn't bring clean boots, and they actually bring the spores with them when they come over. So typical for stadium environments, a really hostile environment, and ideal for fungus, reduced daylight, artificial heating, So the pitch is kept at a certain heat all the time and a reduced ventilation. So it would be easy to, if you know how the conditions are created for a fungus, it would be easy to, or you think it would be easy to minimize those conditions by, for example, applying nitrogen in lower doses and more regular intervals. So basically measure what the plant really needs and apply that rather than give it a boost and wait for 3 months for the grass to live on that boost. Use non-acidic fertilizer, for example, and avoid drought stress. Typical measurements that a ground steam will take. No irrigation in the evening. The grass will stay moist. It doesn't have the opportunity to dry out during the day. So irrigate on the daytime, or at least give the chance for the grass to get rid of the moisture on the leaf. Regular mowing and removal of clippings, a standard maintenance procedure on golf courses and stadiums. And use the UV-C treatment as a preventative measure by applying it 2 to 3 times. What the graph here shows in the research is that we actually looked at the absorption spectrum into the DNA of a fungus. Typically, that's the top line, the somehow purple line. So with a certain wavelength on the horizontal axis, and basically the radiation on the vertical axis. It shows that there is a peak where the absorption into the DNA of a fungus can be achieved, and typically that is within the UV-C spectrum, where the UV-C peaks around that 255 nanometers, as you can see on the green line below. The brown and the blue line are actually UVB, and the peaks for UVB and UVA. So that's it helps. And even the blue spectrum, which is more to the right-hand side of this graph, helps into attacking the DNA of those lower organisms. So the optimum spectrum to apply is 255 nanometers, is what we found, with a certain intensity. Between 50 and 400 microjoules per second, and we found that it diminishes 50% of the spores per application, whilst we're still avoiding to damage the leaf tissue. And also we have done a lot of research in what the effects of these applications are on the chlorophyll rate into the plant, which in the previous webinar told you that that was one of the key ingredients of our research, to follow the chlorophyll rates, because to us that's the marker that we need to basically determine the plant's health. So what do we check? We check the growth of the mycelium in the lab in so-called Petri dishes. We had a certain diameter of fungus into the Petri dish. And we measured it before and after the treatment, and also the spread of the spores, which will typically happen through wind or rain or cross-contamination, as we said before. And the results after this UV-C treatment showed a significant reduction in mycelium growth that you can already see after 2 or 3 passes with the treatment. The treatment reduces that by more than 50%, which you can actually see in the bar on the right-hand side. The control one is the one without the treatment, and the 2/2 one actually shows the short-term treatment with 2 applications, and the 2 beside that actually show the 15 minutes and the 30 minutes application. This is really a high dose at the long-term treatment. And I'll show you in the next graph what that actually does to the grass, because visual aspects show more. So the top 4 grass plugs were the control one, so no treatment received. The second one shows a treatment, short-term treatment with UV-C, and you can see on the left Petri dish that there was a good 5-6 centimeters of disease, and after the treatment you can see how far it has diminished. The two below that with the 15-minute treatment and the 30-minute treatment show a similar reduction or even a higher reduction. But if you look at the grass, it immediately shows what the effects are on the grass. And maybe Andreas, you can elaborate a little bit on this research and what you found.
Yes, sure. On the one hand, as you explained, we want to reduce the growth of our disease. But on the other hand side, we don't want to damage our grass. So here we checked out how much we can reduce the growth of the disease in comparison with the growth of the grass. As you can see, the last treatment, well, we reduced the growth of the disease very much, but we also damaged our grass very crucial here. So we needed to find the optimum of the influence of the UVC light, how much, how long, but with only a minor effect on the grass. So we will have a little bit of damage on the grass when it's not adapted to UVC light, but we want to have this damage as little as possible. So here we tried to see and find what is our right treatment without damaging the grass. And after a while, if the grass is more adapted to the treatment, that damage is also reduced again. But the effect on the disease will stay. So we have stronger grass and also less growth of the diseases. This is what we want to achieve here.
Okay, thank you. So as I said, one of the markers that we follow is the chlorophyll levels after the UVC treatment, and we found that there is a sudden drop of chlorophyll level immediately after the treatment, which is logical because you attack the plant and it will actually retract its chlorophyll into the leaves. But we also found that it's followed by an increase of chlorophyll level subsequently. So after the treatment, it will drop, but it will come back stronger afterwards. We also have some side effects of the UVC treatment. It will react on phytohormones, and I touched on that in the previous presentation. That typically with blue light, that actually stops work of a plant hormone called auxin, and auxin is typically a hormone that wants to create lengthening of the leaf. So by stopping it, you actually increase branching, tillering, how you want to call it, of the plant. So you create a denser and stronger sward, and that same effect is what we've seen with UVC treatments. It reacts to the plant hormones, and it stops that lengthening effect of the plant. So the pitch recovers faster and faster after you've done a more short-term UVC treatments. Another side effect is that it stimulates the cell wall reinforcement. So you create stronger cell walls, which is helpful. It's a stronger plant. It's not as easy to penetrate through a fungus or any other disease, and you create a healthier sward. And this has been tested in the lab. So as Andreas said, it's really the trick is a balanced combination. It's all about balancing. It's not a curative measure where you can kill a disease, forget about it, and don't apply it until the next disease appears. It's something you have to take into account as a maintenance tool on a preventative scale. So you need to apply a balanced combination of the accurate UVC wavelength, typically around 254, 255 nanometers, accurate speed of application. So that basically tells you how long the grass is treated for, and a specific light intensity. And that application we found needs to be applied for the best results 2 to 3 times a week. In the preventative stage, when there is not a high disease pressure, 2 times a week. When the conditions are right for fungus, we boost that up to 3 times a week. And with a 6-meter wide machine, you can treat a full-size pitch in about 30 minutes. So it's not really the amount of time that does it. So the result is that the correct amount of type and amount of UVC light is applied by that machine, and it decreases general fungi or algae infections by 90%. And these are the real figures that we found over 2 years of research in FC Cologne's training ground, which you can see on the background. The Franz Kramer Stadium in Cologne was treated for 2 years. Andreas, maybe you can tell a little bit about that research as well.
Yeah, well, here, as you already told, we have a very good experiment, let's say, because the stadium in Cologne, they did this treatment over 2 years, and so they could all already give us some feedback by what application they did, what results they saw, and because we can do a lot of research, but the example of a real stadium, the real stadium conditions, it's difficult to simulate them in the laboratory or outside the laboratory. In a real stadium, this will be working better and better. And here we saw the progress of, they started the treatment, and after a while, and even after now these 2 years, the effect of the UVC light increased, and the disease concentration was reduced greatly. So here we have a perfect example of how this treatment works. It works not as Rob said, it cannot be applied now and kill everything. It is a process, it is a maintenance you do to the field. If you give a regular treatment with this UVC machine, you can reduce the infections further and further, and also stabilize your field, which reduces your amount of, let's say, fungicide or something like that.
Yeah, that's an important result as well, which I will show further in the slides. So full-scale applications at the moment, Tom, we have a 2-meter wide machine and a 6-meter wide machine available, and I believe there is plans to develop a typical golf course machine as well. Maybe something for you to discuss a little bit about.
Yes, of course. What you see here is a machine that can handle very well flat surfaces like big pitches, also on golf courses. Large flat surfaces can be treated really well. But of course, golf courses, especially on greens, they have also, let's say, an uneven surface with certain relief. And the goal would be indeed to create a machine that can follow the height differences, the shapes of the golf greens, so that it's kind of a sectional machine with different lamps that will work independently, so that we can follow perfectly the shape of the golf green in order to give it the best treatment possible.
Okay, thank you. So if I elaborate a little bit about the machine, if you look at the top center picture, gives you a nice overview of everything that's available on the machine. And the first thing that you see is actually the red and the green light on the top. That's red and green light actually give the driver of the tractor the means of controlling his speed. When he drives the accurate speed, which is about 3 to 3.5 kilometers an hour, the green light will flash. If his speed is reduced or he drives too fast, the red light will flash, and automatically the light application will stop because that will be non-effective. The other one is the jerry can here. Is actually the jerry can that holds the foam for the foam markers on the side of the machine. And you can see on the left-hand picture that the foam marker will show where the application has already been given, and the tractor driver makes his life a bit easier to follow the lines. So the box itself, that's where all the electronics in it. It's connected to the battery of the tractor, and then the power is transformed to give the right amount of power for the light applications underneath. And also there's a little sensor, you can see it here, that actually gives a nice pink signal on the grass surface for the driver to see that the light is actually switched on into the box below. As we said, Helmut Schieke, the head groundsman of FC Cologne's training ground, has used the system in 2016 onwards. Started off with a 2-meter machine, later on with a 6-meter machine. And as you can see from the aerial picture, his training ground is really into a park environment. A lot of immense trees around the pitches, which gives a lot of shade, but also leaf problems in autumn. And he had an immense pressure of disease and algae on his pitches. And in the last 2 seasons, he hardly used any fungicides at all to fight his algae and fungi. And he reduced that amount with 95% of the treatment. Still, he had to use it in some instances when there was really a heavy attack which could not be treated. But the 95% reduction is a nice given. So to summarize, what we found in the research is that the UV-C treatment can reduce the spread of fungal diseases and their sporulations. So we've proved that with our research. The application with UV-C should be done with regular intervals, typically 2 to 3 times a week, to keep the pressure low and to make sure the grass is healthy, and also to increase the positive sides of that UV-C treatment, as we touched on. Part of that is to enhance the plants to become stronger and the sward denser. That will help the treatment as well. Yeah, the indirect effect is that it strengthens the defensive system of the plant and the stability, and also it enhances the favorable antibodies into the plant. And again, that's by not giving the fungus a chance to attack the plant that helps to keep it at a low level. It's more effective for prevention than it would be as a measure after you have a heavy attack of a fungal disease. So the real application is to keep it at low levels, low disease pressure. It does not replace chemicals. We're not claiming that you can forget about fungicides. There will be times in under certain conditions that the immune system of the plant will be vulnerable for disease, and you will need to find a proper fungicide or something else or chemical to treat it. But we are trying to reduce it to a maximum, and in Cologne we found we can reduce it significantly. It does have a direct effect on the quantity of fungi and algae, and it significantly reduces their numbers if it is applied. And the earlier the disease has been detected, the earlier the treatment has started, the faster the pitch can regenerate. That, I think, applies to most diseases. It's up to the groundsman and the groundsman's skills to detect and to take measures. And by applying UV-C, there will be less to detect during the year. Arnoud, I'll give it over to you, I think, at this stage.
Yes, I have a question from the people attending. Have you noticed various light colors control algae? So what's the impact of various light colors with respect to algae? Is there a system, or is there a relationship between light colors and algae development or algae battling?
Andreas, something you want to?
Well, in general, algae are plants, just little small plants, and so they have kind of same reaction types like other plants. But as you know, these algae are very simple plants, so they cannot do the same defensive or growing development effects with the normal spectra we give on the grass. So of course the light spectrum will have a minor effect on algae, but not in the same range as the normal grass types have this effect. So the UV-C light works here because the higher plants have like a definite mechanism to defend themselves against the UV-C light, which the algae didn't not have. So the algae are more susceptible to this treatment than the normal plants or the higher plants. I hope this can answer the question.
Yeah, okay. Got another question. One of the biggest issue with gray leaf spot is the spores are protected by dead leaf, like an umbrella in the rain. Would it be wise to add a blower to try to remove the leaf during control or pick it up? What would be your advice on that?
Yeah, it's always better to collect it, I would say. Same as with grass clippings. If you collect it and remove it, then at least it's out of the area where you want to treat. So if it's the leaves are on your green, I think that's probably what we're talking about. Then yeah, I would definitely remove the leaves before you treat it.
Okay. Basically, that ends the webinar. From my point of view, as you can see on your right-hand side, there are handouts. The presentation of today is in one of the handouts. 2 general brochures are in the handouts, free to download. If you want to revisit this information, we'll make a link available if that's necessary. This webinar will have 2-3 questions to follow in a survey. Would be appreciated if you can take 1 or 2 minutes. It's only 3 questions with a yes/no answer or a multiple choice answer. So would be appreciated if you could fill that in so we can improve next time. Our next webinar next week. We are a multi-purpose company. Our next webinar next week will be on building a circular turf systems from a synthetic point of view. So if you have an interest in changing natural into synthetic and synthetic into natural, that's one of the elements that will be discussed next week. As I said, RSI is a 6 business unit company, and one of the business units is LED, and we have one on artificial turf and hybrid turf as well. So if you feel free to follow next week. Thank you very much for all the attention, and yeah, have a good week. Hope you can work with. Hope we brought you some more information on UV-C. If you feel the need to get in touch with us on products and prices, feel free to do so. Thank you very much for joining, and hope to see you next time. Thanks. Bye.
Thank you.
Thank you, everyone.
Bye.
Good.